cycle, from raw materials or old materials, and you do something, and you fix the building, and then you have to waste it. But there's also other things about the LCA that makes the LCA LCA. And one other thing is that you relate it to the function of the product. And the other one is that you also looking at several types of impact on the environment. You can look at climate change, and you can look at resources, or resource use, and also utilization. So that's LCA. Started in 1969, you say, when Coca-Cola wanted to find out what is the environmental impact of different packaging of bottles for Coca-Cola. And they did energy calculations on their bottles. And at this time, they used more glass, and they were planning to introduce plastic. And people were a little bit, maybe this is not so good. And then they started to do some calculations for them. And what they found out was that plastic was a little bit better than they expected. And do anybody have a clue why plastic is better than glass? No? So something about the weight, for instance, maybe? It's very lightweight to the function of the product. So it's like a liquid, like after you Coca-Cola, you need a lot less in weight material if you use plastic than if you use glass. And that is uses a lot of the raw materials you need, and also like transport in use. For aluminum, it was a little bit other story, part of the story, and that's just the end weight part. So for aluminum, it requires a lot of energy to produce, but if you recycle it, it doesn't require that much energy. So it was very important to find out to recycle aluminum. Okay, that's something you're going to know, I think, but that's time to something more. So in order to make LCA safe for everyone, they started to make some standards in the 90s. This was called ISO 14040 series and 5044. And one of the key parts of the standard is like this set, the goal and flow, inventory, impact assessment, and the page. And these standards are available to buy. But if you don't want to buy them, you can get this handbook possible to download, and you can read most of the important parts of the standards in this package. There's also something called the lifestyle industry, which also has to promote harmonization of LCA, and they have also some guidance online. And today I'll go a little bit through some key parts of this workflow. So one of the most used things with LCA is for carbon footprint, and not only on products but also on corporations. And back in late 90s, they started something called the greenhouse gas protocol. And this is used by many larger corporations to report the carbon footprint. And then they call it Scope 1, Scope 2, and Scope 3. And Scope 1, Scope 2, and Scope 3 is something we can see in many different kind of company disclosures. So, Scope 1 is the direct emission, like from industry processes, use of fossil fuel, and from vehicles. While Scope 2 is the use of electricity and heating. While Scope 3 is emissions not collected from the company, but from suppliers or transport, and also be used for waste treatment of the product. And for many companies, Scope 3 is the most important source of emissions. But it's really difficult to get data, and that's where we use LCA and LCA database for Saturday. One source of LCA data is environmental color declaration, and these are a standardized way to document the results of one LCA. They don't just build on one LCA standard, but you have one standard for EPD, and then you have one standard for active standard for EPD on construction. And then you have another standard for EPD on cement. And you have one standard for wood, and you have one standard for glass. So there is a lot of standardization behind EPD. But when we look at different practices, also not so easy actually always to know how it works. And as Doyle mentioned with the COP, which is wood and wood, the transport can be quite important. You mentioned wood from Romania going to Austria and going back to Romania. But some of this is also going from Austria to Romania, maybe to Austria and then to Norway. And how do you calculate the transport from Austria to Norway? And that includes some things that people do not always agree on. And this is because this truck usually have to go there and they have to go back again. And how to separate the emissions from the whole journey is not something very clear. But this is something that we are continuously working on. So about 10 years ago, they released this standard called BIM-LCA. And it's somewhere talks about A1 to A3 and B. It's from this standard. And this is the standard for a construction product. And when it was released, it made some more specific requirements on the LCA. And you can also see that the rise in availability for the last 10 years has gone quite up from about 1,000 10 years ago on construction, and now more than 10,000 available. And usually going in business to anything. What you can also see from this graph is in different countries. So you have the different colors, which the different countries and how many EPDs they have in their EPD program. The larger colors are like US, France, and Germany, which are quite large country. But guess who is in the fourth place? Norway. They normally have a lot of EPDs compared to the country. Why do they have a lot of EPDs in Norway? Yeah. Yeah, between beer and the economy is all European. So in Norway, I think there are several parts of the story. One is that it's something about collaboration, and that makes sense why we also do the collaboration in the project. Some parts could be that in Norway we have very green electricity. So if you make an EPD for a product, you're much better than the others. And that's a good reason to make EPD. I think that's the most important reason I know. One very difficult part of EPDs is that you require a lot of indicators. So they're all standardized, and everybody has to agree on the methods. And that means that we add a lot of requirements. And one of them is the different impacts of the environment that we look at. So it's not just carbon spread, but it's also energy use and also electrification. And yeah, I think it's something 44 different implications. And this is why we use software. Okay. Was also been working on that when these were available, the format it was in 4 pages in Norway, it was picked up, and then it was always available in PDF. In the last year, they've been working a lot to make it machine readable, so the software can support EPD without typing and writing and data. One part which we should know about, but not worry about, is there are 3 general types of LCA. One is called consequential, and one another is called attributional. And attributional is what most people use, and what EPDs and building LCA is based on. And the basic idea is that it's kind of accounting how much emissions this product has. And it means that if you want to look at window manufacturer, you collect a yearly amount of energy used, and then you calculate the amount of energy involved windows. While consequential, it's more about how you change energy or impact. And this is something more used maybe in policy, but they don't have so much standards with how to do that. So this is something about the golden scope, and I'll tell you know a little bit more about the inventory. And inventory is the part where you need to do calculations and get data. So it's where we spend a lot of time and effort. So in order to make LCA possible, we used a lot of data. And some of the sources that we have is from databases. And these have usually raw material. They have transport and the waste. But we work with industry, you need to collect some specific data from the manufacturing of the product. So for instance, from a window, you need to know how much different material, glass, wood, or aluminum and plastic that is required from the window, and also where it comes from, and also how much energy and how much waste is it in production. So how to produce the glass and all the raw materials, we collect those from our database. These databases are in LCA called life cycle inventories, and they're structured like a unit processes. And these include all the raw material, all the emissions, all the weight, and products, and useful raw material from one manufacturing process or raw material platform. This is a little bit different, like you would see if you work with some software. It's calculated. But this is generally how general LCA is done. And one of the important things that I will tell you about later is how to separate between different products. One of the important good things with having data as unit processes that we can copy paste these processes and change data. So you can change the electricity, you can change the amount of raw materials and energy, and adapt it to different kind of needs. And also with this inventory, you can look at different types of environmental impact. So this is one example of user process for forestry. And this includes forestry here, inputs from technical and inputs from environment. The inputs from the environment includes the carbon uptake, it includes the use of the land area, both use and the change of land area. While the input from technical is what we need from other parts of the industry. So it will be the energy used, diesel, and also the machine that we need for it. And also the gravel to make the road the forest. And when you do LCA of a building, this is part of the calculation that you need to make the machine for the gravel that you need for the road, the forest to make it look for the field. So there's a lot of in LCA that are active. One of the crucial parts in LCA in general is allocation. And this is very important also to connect with a good product. Allocation means that you have many industries producing several products. So in wood, you make strong wood, and you will get in products, you will get in chips that are used in other kinds of industry or for energy. And you have to separate the environmental impact between the main product and the byproduct. One way to do this is that it is something called subdivision. And this is the preferable way. So you try to separate in like a formula how much energy is used for wood chip, or how much energy you use for the solid wood that you will use in the final product, and how much you will use for the polish. And what you will see there is that some of the products it requires drying, for instance, and that requires a lot more energy than if you just doing normally in the first part. But even though with the stability, you will need to allocate results from up to forward. And for this, you have several different approaches. And one of them, which is the simplest one, is to allocate all the impact to your main product. And this is what we see here with the blue one, where it's 100% with the small number. Well, the two other graphs here are two other types of allocation. And one is physical, and the other one is economic allocation. And physical allocation is something that people in engineering like because it's very calculated and it's constant all the time. And it means that you divide the impact with the mass or the volume of the site. And with this one, the one where the blue is the lowest, where the solid wood or the wood for construction has the lowest impact, but you will have more impact from products from water. While economic allocation, the reason to do that is that industry is driven by income. You generate economic from the main product, and for that, you need to allocate more impact to the next product. That will be higher impact on the lower. So I'll talk about impact assessment. Impact assessment is about different types of environmental issues that we look at. Often we talk about climate change. This is the most common impact to look at in LCA. But you can also look at other kinds of environmental impact, like toxicity, acid rain, particular matter, and also like plastic and microplastic. There is a lot of different types of environmental impact you can have. And from a vehicle like this one, you can have what we call tailpipe emission from CO2 and also sulfur oxides that are local emissions and particles from the tailpipes. But there are also emissions like from the tires and the brakes that are part of the inventory of that plant. During impact assessment, there's also calculations. Usually you don't need to worry about these things because they are usually included in standard and in software. But what they do is that they are transforming the emissions to one indicator. For climate change, we have this indicator called global warming potential. And what this indicator does is that they are calculating all climate-related emissions in one indicator. For instance, you have methane, and you have nitrogen oxide, which have an impact in climate, which is not higher than CO2, and but you are calculating in that CO2 equivalent. And we have also some other types of greenhouse gases that have a lot higher impact. These are called certification factors, and there are this one field of LCA, which many people don't work so much on, but this is how we use that. What you should know about these factors in this table, it's a little bit small, but I will explain the most important one part. And that some of these impacts is quite robust in the method, but some other impacts is really uncertain. So for climate change, this table would say it has a robustness of 1. So it's quite robust. For eutrophication, it's robustness 2, while toxicity is on 3. So it's really uncertain. If somebody says to you, LCA and this product is good, but for toxicity, it's really not so certain. So some cases where you're done, the impact depends a lot of like soil conditions where this product is used, and usually you don't know about it. While for climate change, it doesn't really matter where the product is used or the emission takes place. So if you go to atmosphere and like it will also. So for climate change, it doesn't matter if it's the same or if it's nowhere. That makes it much more difficult. So there's also some costs involved. This is a survey on the cost of the LCA in EPD. And for me, I've worked with this and this makes kind of sense. This is different steps that we need to go through with collecting data and doing calculations, working and getting it verified. So you can hit between 10 and 30,000 euros when you do. So for big operations, it's nice because you're more competitive than the small one. But for smaller businesses, it's more difficult. So to make this possible, you have software. This will be demonstrated afterwards. But mainly we have Excel, quite straightforward. We have general LCA software, and these have a lot of data, but you need to be kind of an expert. And we have more specific software for design and building. And you will see that later with Ramsa and with LCA. We have this standard, but I made some workflow that is a little bit more simple work. And what we start with, if we're going to do LCA, is to check research and see what people have done before. From this, you will get a database on the data and the functional view. If we have access to Cinema 2 or other LCA software, really good to check return there on the inventory. So if we're going to do LCA on a window, you can go and check what kind of material is typically used and how much impact